Let's talk about ground faults, what they are and what they do. Understanding behavior, not just definitions. One fault is a warning, two faults can shut you down. What is a ground fault? A ground fault is an unintended connection to ground. A conductor contacts grounded metal or earth. The system is no longer electrically isolated. The circuit now has an unintended path to ground. Field language. In the field, you will hear short to ground. Clarification, not all ground faults are dead shorts. Some are resistive, intermittent, or hidden. Both are real, but not the same. A floating system. Most fire alarm circuits are intentionally isolated from ground. No intentional connection to ground. Both conductors are isolated. The panel monitors for unwanted ground connections. Ground is an abnormal condition. Why ground faults matter? One ground fault usually creates a trouble condition. Two ground faults on opposite conductors can create unintended current paths, can create short circuit conditions, can interfere with operation, can cause erratic system behavior or failure. The first fault is your warning. The second fault can become your failure. What your meter tells you. In a balanced floating circuit, both conductors often show similar voltage to ground. A soft ground fault, one conductor drifts towards ground, the opposite conductor shifts away from ground. A hard ground fault, one conductor drops near 0 volts to ground. The opposite conductor may show full system voltage to ground. Voltage behavior tells the story. Why voltage shift happens. In a floating circuit, neither conductor is intentionally connected to ground. A ground fault pulls one side towards ground. The opposite side shifts away from ground. The circuit is no longer balanced. Hard versus soft ground faults. A hard ground fault is a solid connection to ground, usually lower resistance, stable and obvious. A soft ground fault, resistive or intermittent path, higher resistance. They're often difficult to locate. A hard ground fault, the field view. A hard ground fault behaves like a short to ground. Causes could be a pinched wire, a screw through a cable, direct metal contact. Meter behavior, voltage on the faulted conductor collapses nearly to 0. Soft fault field view. Soft ground fault equals leakage to ground. Causes, water intrusion, one of the most common causes, damaged insulation, contamination, loose strands of wire, internal device leakage or failure. Meter behavior, voltage shifts instead of collapsing to 0. Readings may drift or fluctuate. Multiple ground faults. Two ground faults on opposite conductors can create short circuit conditions, cause unstable voltage readings, create erratic system behavior, interfere with normal operation. Do not trust a single measurement, isolate and confirm. Real-world causes. Common causes include moisture in conduit or boxes, pinched or damaged conductors, staples or fasteners through the cable, loose or stray wire strands, improper terminations, corrosion or contamination, or an internal device failure. Troubleshooting mindset. The panel is not a meter. It tells you a problem exists. It does not tell you where. Confirm everything with measurements. Step 1. Identify the faulted circuit, whether it be the SLC, a NAC, IDC, aux power, or other panel-powered circuits. Use panel information as a guide, not as a conclusion. Labels can be wrong. Circuits can be shared or mislabeled. Step 2. Check to ground. Measure voltage from each conductor to ground. Check resistance or continuity to ground. Voltage shows imbalance and behavior. Resistance confirms a solid path. Use both. They'll tell different parts of the story. Before measuring resistance, de-energize the circuit. Disconnect from the panel if required. Never measure resistance on a live circuit. Additional considerations. Capacitors and electronics can affect resistance readings. Allowed stored voltage to discharge before testing. Ohms is power off always. Volts you measure with power on. Step 3. Split the circuit, divide and conquer. Divide the circuit in half. Test each side. Keep narrowing. Often the fastest way to isolate the fault. Step 4. Inspect the section. Look for moisture, physical damage, loose or stray conductors, foreign objects or debris. Step 5. Fix and verify. Repair the cause, reconnect the circuit, confirm readings return to normal, confirm system status returns to normal. A field snapshot. Panel shows ground fault on a NAC. One conductor reads near 0 volts to ground. The other reads full voltage to ground. Fault is isolated by splitting the circuit. Follow the process, don't guess at it. Common traps. Assuming all faults are shorts. Trusting the panel instead of measuring. Ignoring intermittent faults. Missing loose strands or contamination. In summary, a ground fault is an unintended path to ground. A hard fault is a solid connection to ground. A soft fault is resistive or intermittent path, such as water. Voltage behavior helps identify fault type. One fault is a warning, 2 faults can cause a failure. In closing, the panel reports the problem, the meter explains the truth.